All right, so either study hall or your lunch period, okay? So that's today, February 3rd for you. All right, Mariah, do you think you could take down the second light from the left? Thank you very much. Is that too dark for you? Yeah, that could you do one more favor? That backlight. The fourth one to the here you go. Thank you. Could you turn that on? Appreciate it. Awesome. All right. We're going to go ahead and get started off right away with a warm-up. Just want to say good morning to everybody. Those of you that are on Zoom, Mr. Renshaw and I are kind of trading off some duties today. So I haven't seen you in a couple of days. I've seen you. I just haven't been talking very much. So welcome. Those of you in person, I've seen all of you yesterday. Welcome back. Thanks for making it 2 days in a row. Sometimes that might sound like it's not an accomplishment, but in this world, it is right now. So thank you. All right. So what we see here on the screen right away. Okay. And again, I guess one other thing, as an observer yesterday, I want to say thank you for all of you that participated, that moved around the room. And then also for those of you that discussed online, our existence and that kind of stuff and how we view the world on a daily basis. That was wonderful and exactly how I saw the lesson plan going, and Mr. Renshaw did a good job of facilitating that. So that being said, our warm-up for today is going to start like this. I'm going to share the full screen so that I'm not confused or the present. Here we go. All right, so what we're trying to do here, okay, for us to move forward here and how humanity kind of functions to the point we are right now is we've got to be able to connect events. And so we're looking at 3 events that happened in Western Europe, but would eventually affect most areas of the world. All right. And that is first the Renaissance, which was the rebirth of Greek and Roman learning. Most of us remember that. Then after the Renaissance, shortly after, you had Martin Luther and then other men, religious reformers, question the church, start to point holes in the church. And then you had the scientific revolution, where the scientists felt like they could now start to question other things. Okay. So what I want you to do is, in your mind, critically think for a second and try to write one sentence that combines these 3 events. Okay. And please go beyond. In Western Europe, there were 3 movements called the Renaissance, the Reformation, and the Scientific Revolution. Okay, try to combine these 3 into one idea. We're going to set a timer for 3 minutes. And so we're going to take attendance during those 3 minutes, and you are going to go ahead and put this in the chat box, okay? For those in the room, we're just going to discuss, okay? And we've got 3 minutes to do it. So start now. Okay. the room. What we got here. So those of you that responded, I only got 7 people. Remember, of these 16 of you on here, this is how you receive your participation points. Okay, so just a reminder, you want to make sure that you are participating. Michael Dunn stressed that they were part of our education. We have Zariah saying that goes back to the Greeks, reform of education and reform of the arts. The rebirth of Greek Roman learning caused people to question the church. This caused scientists to have more power. Awesome. The Renaissance and the Reformation both sparked the scientific revolution because the new ideas about religion and art, other topics probably need to advance too. Good job. Okay, this shows me that Mr. Renshaw is teaching you the correct ideas here. So kudos to him. All right, this is great. Yeah, so everybody that has responded has done a great job here. Okay, and in class, we came up with the idea that it was bringing back learning, which caused questioning, which then caused discovery. And we kind of agree that that's kind of common sense, but it's only common sense because that's how our education is based today. Okay, we've got to question things to be able to change them, right? And so this is an important part. This is an important mold of who we are as people. Okay, do we understand this? If something is being done wrong to you, if something is wrong, and you know that something is right, do you sit here and accept it? I mean, I know. Most of you, and we talk about this first semester a lot, in all of the different social justice platforms that you guys use to share, and we talked about a lot of injustices in the United States. We didn't sit back idly and say these should continue, did we? Jacob, did we? No, show some emotion. Wake up. Daniel, get your hand off your face. Okay? Come on, man. This is active learning, all right? Thinking. Okay, we're gonna move on today, finish up a few of these scientific what do we call them? They were actually more like at the time considered philosophers because science was not cool. If you were a scientist, you would be put in jail or you had to have permission from the Pope. Okay. The Pope didn't give out permission to scientists very easily. There was only like a handful of universities where studying of science was allowed. And so these guys were more like garage, making stuff in the back of their house or their garage. They didn't have garage at that time, so probably in their basement, all right? These guys might be looked at as a little weird on the street, okay? People might think of them as like the weird uncle, all right? Because they didn't do what everyone else did. Does that make sense? And so somebody in first period yesterday or second period asked a great question. They said, how come this guy has a portrait made of him? Well, the guy's got a portrait made of him because he ended up being famous. Maybe that was later on in his life, but he didn't become famous at the age of 15 or 18. These guys took 20, 30 years to study and have to come up with this and then have the guts to come out with it, their discoveries, all right, before they became even remotely famous. And most of them became famous after they died, let's be honest, like Shakespeare, okay? All right, let me ask Mr. Renshaw a quick question. Is this following their notes chart from yesterday too? All right, so this is a perfect place for you to add to that notes chart, okay, that you had yesterday. So if you want to just add main idea, I'm going to be going pretty quickly. Mr. Renshaw made some slides that are definitely from a era of technology that is cooler than mine. All right, so you should be impressed with these, but you should not write every word down. If you write every word down, you will be writing until tomorrow morning. Okay, we don't do that. All right, write down main ideas. Let's move. So first man we're looking at here is Sir Isaac Newton. Take a look at the pictures here. Take a look at that guy's nose. It's pretty pointy. Had some serious flow. That's not a wig, man. That guy had hair. Around his age, how about how much hair left? What do you think, Adam or Mr. Renshaw? He said what's done is done. All right, so how do you get the name Sir? That's crazy. How do you get a name Sir? Man, I want to name Sir Daniel Brunette. How do you get that? Yeah. You have to be what by the queen? Okay, you got to get it from permission from the queen or the king. Anybody on Zoom know how you get to be a sir?
Aren't you like knighted?
You can unmute if you want. Yeah. I'm going to turn the sound up. Sorry about that.
Aren't you like knighted?
You have to be knighted. Excellent answer. So you were on the right track, Nate, Nathaniel, Nathan, however you want to go by. Sorry. All right. Yeah. So obviously later in his life, he was very famous. Also want you to see how long he lived. 58 plus 27. I'm not good at math. What is that? Anybody want to help me out? 1642 to 1727. How many years is that? 58 plus 27. That's got to be somewhere in the ballpark of, is that 80? Dude lived 80 years at a time when most people lived like 45. Is that impressive? Yeah, so that's why he was able to come up with so many foundational things. The first one, maybe you used in middle school. If you haven't used this yet, you're going to. It's called the laws of motion. And that basically everything, every force, what is the whole term? I haven't studied this since I was maybe a junior in high school. Every force has a equal and opposite reaction, or something like that. Force equals mass times acceleration. I just remember my chemistry and physics teacher like over and over again. You got to manipulate this equation. But the theory of gravitation was pretty important. You guys, I think, understand that, or you understand that, when you drop something, it falls because the Earth has magnetic pull. That was a big thing. And then really the one that I wanted you to follow the most, though, and this is most important for us tomorrow and moving on here, is that all of nature follows the same laws called uniform law. And that is force equals mass times acceleration, and that is gravity. Now, why is that important? Hear me out for a minute. If all of nature follows uniform laws, do humans follow uniform laws? That's the question, okay? So that's where we're going tomorrow, is how do we take these guys who were renegades, rebels? In England, he was liked. Most of these other guys were not liked. How do we take their ideas and then turn them into how it affects us as people? Okay, and that's what we're going to shoot for tomorrow. All right, let's take a look at Robert Boyle. You'll notice didn't live nearly as long, okay, if you look at the years. But he is the father of what we call modern chemistry. Back in the day, they thought chemistry was called alchemy. They literally thought if you took the right kind of pills, you could grow a second or third nose. Okay, you could maybe grow an extra pinky. They had no idea. Have you ever read the book Frankenstein before? Okay, I mean, they had really very little concept of how chemistry and how chemicals worked. And basically through his study, he's going to figure out that everything is composed of tiny matter. And the most famous equation that Boyle was known for is P1V1 equals P2V2. It's on the bottom left. Okay, if you have never, has anybody in the room used that equation before? Okay, that's like chemistry 101. That's about the first equation you'll get when you get to chemistry class. All right, and this is basically pressure, and how pressure creates force. That's what this fancy little diagram is showing you. It's the atoms being pushed together, the molecules. Again, I teach history. This is about a stretch for me, as much as I go. All right. Another man, Anton von Leeuwenhoek. Maybe the best thing about him is trying to say his name out loud. He invented a microscope, though. Okay. I know in freshman biology, at least, they used to talk about this. Did they mention it this year, folks? No? The guy who created the microscope. Check out his microscope. But honestly, most importantly, is he's the first to come up with the cell theory, which obviously is very important even today. I was reading, my mother just got the second dose of the vaccine, and it's attacking her immune cells bad. She's not feeling great. And my sister got it because she's the nurse or PA, and she said that it took her a couple days to get over it, but my mother, who's older and not as healthy, a lot worse. So I don't know, stuff that, obviously we have I've had friends who've had cancer. I had cancer of my own. I had cancer myself when I was 22. And I had to have, I didn't have to have chemo, but I had to have a lot of skin removed because it was skin cancer, but it was because they found a basal cell in my shoulder. So thank you, Anton von Leeuwenhoek, for finding cells. Descartes. All right. So here we move into another guy who was a philosopher, scientist. Again, part of these group of men in the mid 1600s who started to question. And he started to kind of move towards humans and trying to understand what is knowledge. Okay. How do you know something is actually true? Okay. Let's say those of you on Zoom, okay, those of you on Zoom right now, those of you who are actually paying attention and not sitting there like bums, I want you to tell me what color the main color of my jacket is that I'm wearing. Okay.
Black.
I know that, Michael, but put it in the chat box, please. Okay. There you go. All right. We're going to mute for about 10 seconds. All right, we got a lot of answers. We got black, 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 and black, black from different people. The whole class said black. How do you know that? You don't know that. You guys are looking through a computer screen and accusing me of wearing a black sweatshirt. I mean, this could be an optical illusion. I could have had Mr. Renshaw flip this color screen on my computer and changed it, right? And I could just be messing with all of you, and you wouldn't even know it. How do you feel about that? Crazy. Now, let's be realistic. Yes, this is black. I think it is. I don't really know because there are so many different shades of black, right? And every other color. But I asked someone, how do they know that this was, Ian said, probably because you probably don't know how to change colors on Zoom. That is 100% fact and provable because I wouldn't be able to do it. So thank you, Ian. Nate said, we were taught this. Yes, I was taught, that Jordan Bullock has a blue stripe on his sweatshirt. But we know that because it's been proven over and over and over again, tested over and over again. Okay? So that when we're taught it, it is fact. It's knowledge. And so Descartes came down to the foundational idea that the only reason he was a person was because he could process his thoughts. Okay, that's the only way he knew he was real. Now, that adds to Bacon, which then who came up with this thing called inductive reasoning. I'm going to break it down to even more common sense, and that is the scientific method. Okay, every year, except for maybe the last two, I used to have students just write this on their intro. Is it on the intro? Might be on the intro too, because all the scientific method is you state there's a problem. You try to make a guess as to how to solve it. You experiment. You draw a conclusion. If it's not right, you do it over again. And obviously, this is a way to find out if something is what, Jordan? Right. Yeah, correct. Excellent. So this is how we identify truth and knowledge versus untruth and unlogical things that were socially accepted at the time. Are some of you starting to get the point of where I'm going with this? Yeah, there were some injustices in society that had to be pointed out. Okay, and then you continue to go to the year 2021. Do we need to go back to the scientific method here? And maybe show that we can adjust some things? Yeah, I think the summer of 2020 pointed that out, which had been there for hundreds of years. Okay. I mean, it goes back to the first humans that walked the earth. All right. We got to remember that. All right. So that was bacon. Not like the bacon that I put in my egg casserole last night, but Sir Francis Bacon. Sir, that should give it away that hey, he was English, so he could be a little bit more of a renegade, because English, as Mr. Renshaw taught you last week, had a little bit more stable government situation than the French, where you couldn't do whatever you wanted. French would just kill you. All right, so let's kind of sum this up. All right, this is going to be it for kind of the scientific revolution, the so what. Okay, basically, all I have on here, the top two things you don't need to write down, but the bottom one is important. Okay, and it is the so what is how do we apply these natural laws that these scientists came up with? Okay, cell theory, pressure, gravity. Okay, the nature acts in a consistent manner. Are we part of nature? If so, how do we interact with nature? Are we conditioned to be the exact same and have the exact same patterns? If so, how do we figure out how to not kill each other like nature does? Because what these men pointed out was that in nature, one will kill, like if a parent and a child are left and they're the only things around, what will the parent do to the child in nature? What's that? Eat it, because it's hungry. It's terrible. It's awful to think about, but that's how nature works. Now, if we're a part of nature, are we going to kill the person next to us for food if we get in that situation? I'm not here to say yes or no. I'm just trying to get you to think. Think about that, okay? Because if we aren't, we've got to figure out a way to coexist, correct? We have to figure out a way to coexist. And so that is what we're going to be looking at tomorrow. And we're going to look at a second group of men and women that come up with some ideas that at the time weren't socially acceptable, but have changed our lives and are continuing to change our lives to this day. All right. Here's what I want to do. I'm going to shut down this little slide share thing. Just a reminder, it is on Canvas. So obviously you can print it off if you want to, look it up. You got notes chart. You can also follow all that good stuff. All right. What I wanted to do with everybody is I wanted to make sure you were comfortable on these intros. I know for some of you, you're going to go, well, Mr. Burnett, I got this done in like 30 minutes and I'd finish it on Monday. Some of you are going to go, I haven't started. So I want to do everybody a favor and just kind of walk through this with you and have you help me as we do it. And once we get through to 11, we're going to call it a day. And then the rest of the class is yours on Zoom. You guys, you can either finish, keep reading, or you can go to the bathroom and make your Pop-Tarts. Ethan, I know you probably want to go get some breakfast. So something like that, right? All right. So I need, I see Francesca. Can I get a thumbs up if you can see the intro? Great. All right, Mariah, I need a confirmation you can see the intro on the board. What's that? Okay, did you say sure? I don't know what that means. It's like saying yes and no at the same time. I'm always confused. Yes? Yeah, good. All right. All right, so what was the key to new understanding for leaders of the scientific revolution? If you already finished this, get it up on your screen and help me out. If you want to participate on the Zoom, use some kind of hand share or something under, what is it called? What are these? There's under the more tab, and they changed this thing around on me. Remote control. How do you use thumbs up and stuff anymore? Participants. There it is. What? Jariah, go ahead.
Mathematics.
All right. What was the key to new understanding for the leaders was using math. Good. And using new tools. All right. What did Copernicus challenge and what was Copernicus' idea? So review from yesterday. Anybody want to help me out? Number 2. Anybody in the room too? Yeah, Mariah. Bingo. Big one there is he challenged the geocentric model with the heliocentric model. And helio was center at the sun, the center of the universe. So the sun, the center of the universe equals helio. It's probably what you want to put down there. All right. What did Kepler add to that? Should be pretty simple, I think. Oh, yeah. I remember this from when I used to teach this. What did Kepler add? Anybody want to help me out here? Someone want to raise their hand or talk? Yesterday. Oh, here we go. Go ahead.
He believed that the planet orbits were not circular but elliptical.
Yeah, elliptical. Ian, have you made ellipses yet? In math class?
No, I mean, even if we have, I probably wasn't paying attention. So
At least you're honest. So ellipses are there's something that you do a lot, actually in algebra 2, or what do you guys call algebra 3, 4? You're gonna have to make a lot of ellipses. So you'll remember Kepler. All right, let's go to 4. What did Galileo add to Kepler and Copernicus's idea? I'm gonna go ahead and just throw this one out there for you. So I would answer, he discovered the moons, Earth's moon, and the moons revolving around Jupiter. We'll go with that. It's a bit of a random question. Would be my fault. Let's talk about 5 here. How did the Catholic Church react to Galileo's findings? They were very upset. Okay, and he lied to the church, and then he broke his promise. So Galileo was the only one of these men who lived in the like the Catholic part of the Holy Roman Empire. So they made him come to Rome, and that was where he was put to trial by the church, saying that if he got convicted guilty, he would be killed. But he lied and said he said no, the sun. Basically, he said, "Oh yes, you're right. The heavens are in a fixed position." And then when he's walking out of the trial, he goes, "No, but the earth revolves around the sun." And he said underneath his breath, famously. And so they didn't convict him or kill him. They put him on house arrest, though. So he lived the rest of his life on house arrest because he upset the church. All right, what is the universal law of gravitation, and which scientist came up with the law? We just went over that. That was Newton, I believe, Sir Isaac Newton. And gravitation was that all things are held by a universal force, right? Crazy concept, if you really think about it. All right, let's split this up. We have the following 4 scientists. All of them did some really cool stuff. Sometimes I talk about it, sometimes I don't, but you're not gonna have to remember them, but it's just kind of interesting to see that this type of science or study of the body came up or was done in this time period. So Vesalius, what did he do? Anybody catch this in the intro yet? He studied at Padua. I've been there before. It's a cool city in Italy. But basically, he was the first person to cut open dead bodies or corpses. How many corpses? To study the human anatomy. Okay, basically, once someone died, the body was still sacred to the Catholic Church, so it was illegal to touch the body. If you go to med school now, the first thing that you do, even in dental school, I've had a couple of friends do that. The first thing you do is you get a half a body, a human cadaver, and you go in and you dissect a human. And that's how you learn about how all the organs and everything function. You know how people donate their body to science? Well, that's what they do. So someone dies in a car wreck, they'll use that body at the IU clinic downtown. Seriously. I thought it was really weird too, but yeah, they even give them names. So this is the first guy to do that, to study how the human body worked. Okay, then I think Harvey added to that, and basically he proved, if I remember right, that the circulation of the blood in the body. And he used Vesalius' sketches and his own sketches of dead bodies to do that. Pascal, I thought, liquids behaved under pressure. So that's his law. What's that? Oh, okay. I was like, so Pascal, I believe, was I'm not right, it's like germ theory. Good thing. It is pressure, actually. You're right. Yeah, so Pascal's law is pressure equals force over area. So basically, how much force is being given by a particular object. And so his famous equation, pressure, that's P, equals F over A, force over area. So you guys didn't know we were getting into math class today? We are. Pressure equals force over area. All right, and then Boyle, I thought we already talked about Boyle today, but he took the pressure thing even further and understood gases. So his was P, it should be a subset 1, but I forget how to do that on a computer. P1, V1. Just laughing because if I was teaching math class right now, I would be a massive fail. Is equals P2, V2. Yeah. Basically, Boyle's law is how you figure out pressure as well. All right. How did women impact the scientific revolution? Anybody want to help me out with that one? Anyone in here? Did you get that far? This is good. We're doing this. Jacob, do you have it already? Chris, you got it? All right. Anybody on Zoom get this far yet on the intro? Zariah, hit me.
Didn't they help with astrology?
Astrology, good. Margaret Cavendish. Maria Winkleman as well. So astrology, remember, women, this was still a patriarchal society where women didn't have many opportunities. So this is also kind of part of this social movement that's occurring, is that women start to get to branch out of just being the homemakers. What was the main idea behind Descartes? Basically, he figured out that he could think, so he was alive because he could process complex thought. They basically, I think, therefore I am, is what you want to remember there. 10, rationalism. It's exactly what it sounds like. Basically, I'm going to type this one out for you because I need to remember it myself. But rationalism is basically if something is not provable, it is not correct. Rational. Maybe you've heard someone say, like, that's irrational or that's rational. That's where that comes from. All right, last one, and we'll pick up with these other ones tomorrow. Who came up with the scientific method and what are the steps? Anybody remember from today who came up with the scientific method? It was another Sir.
Sir Francis Bacon.
Sir Francis Bacon. Nice job. Thank you, Ian. And Chris, thanks for raising your hand. I know you were on top of that. And the steps. Luke, thank you as well. The steps are the scientific method, which you've been using since like what, 4th grade? Yeah, I don't really want to type that out. I'm too lazy. So I'm gonna just kind of call it that. All right, so tomorrow we're gonna talk about reason. First thing in class, we'll talk maybe a little bit about the philosoph. These people are gonna help us with the French Revolution next week and after the week after that. And deism, Mr. Renshaw hit on that a little bit yesterday, but deism just is a belief. 17, just the belief that there is a God. He put a natural order into the universe and then he left. All right. It's not the same personification of the God that Christians, Muslims, Jews think of. Okay. It's just a God who put order to the earth. The rest of these are ones that we're going to rip on tomorrow. And I believe Mr. Renshaw changed the intro to being due tomorrow. Okay. And I think that's good for everybody here because it seems like, I know there's a few of you that have it done and maybe you're just being quiet, but this gives you all a little bit extra time. Michael, you have your hand up. What's up?
Oh, my hand was up because of the Sir Francis Bacon part.
Oh, I appreciate that. Some weird, like the hand raise stays, but the yeses and the nos don't stay anymore. So I had to figure this thing out. All right, I'm gonna go ahead and say you've got about 10 minutes, 12 minutes till the bell rings. I want everybody on Zoom to stand up, stretch, okay? Take a brain break for a minute or two, and then if you could get a few of these questions answered so you have a little bit of background knowledge of where we're going tomorrow, okay? So go back into the textbook if you don't mind. Answer a couple questions. All right, thank you for your participation, everybody. If you have a question for myself or Mr. Renshaw, stay on. If not, get out of here and have a fantastic rest of your day.
Have a good day.
Thanks.
Thank you.